Okay, let's continue with the one-sided limits again, and let me give you an example. And let me give you a graph, and after that I will ask questions to 4, 6, and okay. This is our function, and this point 6 comma 2, okay, and this point is 1 comma 4, and this is the minus 4 comma 2, okay, and this point is 1, and this point is 1 comma minus 2, right? And this point is 6 comma 5, and questions about the one-sided limits, okay? And so A, what is the f of minus 4, and the B, limit x equals to minus 4 from left hand side f of x, okay, and the C, limit x equals to minus 4 from right hand side f of x, and the D, limit x equals to minus 4, okay, and the f of x, okay, and the E, f of 1, and the F, limit x equals to plus 1 from left hand side, and the G, limit x equals to plus 1 from right hand side, and the H, limit x equals to 1 f of x, and the I, f of 6 and the j limit x equals to 6 from left hand side, and the k limit, oops, I'm sorry, x equals to 6 from right hand side, f of x, and the L limit x equals to 6 f of x. Okay. And what can we say about the f of minus 4? Okay, as you see, f of minus 4 does not exist. Okay, why did I say that? Because there is no closed dot for this value of x, and so the function does not exist at this point, as you see. So does not exist. Okay, and the b, when the limit x approaches to minus 4, when the, what was the limit f of x? Okay, and from the left hand side, as you see, when you approach minus 4 from the left hand side, okay, your value will approach to the plus 2. So we can say for that it's plus 2. Okay, and when x approaches to minus 4 from the right hand side, okay, your value will approach to the plus 2 again. Okay, so the function is approaching a value of 2 as x moves in towards minus 4 from the right, and the d, we can say it equals to 2 because of the facts. Okay, and that means either we can use the fact here and notice that the two one-sided limits are the same, which is 2, I'm sorry, and so the normal limit must exist and have the same value as the one-sided limits, or just get the answer from the graph. Okay, you can easily see. Okay, and this is a limit point. And the e part, okay, f of 1 equals to, as you see, 4, and when the limit x approaches to 1 from the left hand side, okay, as you see, from left hand side it will approach to the 4, right, and when you approach to 1 value from the right hand side, okay, and as you see, the limit will be minus 2. Okay, from the fact, okay, and the left hand side equals to 4 and the right hand side equals to minus 2 towards the x equals to 1 point, so normal limit does not exist. Okay, which is h does not exist, right? And the last part of the question, it was f of 6. Okay, f of 6 equals to 2, as you see, and when you approach to the 6 point from the left hand side, okay, and your limit will be 5, okay, and when you approach to the 6 from the right hand side, okay, your limit will be 5 again, and the normal limit will be 5. Okay, I think that's enough to understand clearly one-sided limits. Okay, and let me continue with the limit properties. Okay, and the limit has almost come for us to actually compute some limits. Okay, and if you want to prove these limit properties, okay, you can find extra chapter of your extra chapter in your book, okay? And I'll give only property, and I don't want to prove all of this property, okay? So the first one, and let me write the first. We will assume that okay, limit x equals to a f of x, and limit x equals to a g of x exists, and c is any constant. That means c is any real value. Then first property, limit x equals to a, okay, and the c times f of x, it equals to c times limit x equals to a f of x. In other words, we can factor a multiplicative constant out of a limit, okay? That means, and the second property, and the limit x equals to a f of x plus g of x, or plus or minus, I can say it, and it equals to limit x equals to a, okay, and the f of x plus or minus, okay, limit x equals to a g of x. So to take the limit of a sum or difference, all we need to do is take the limit of the individual parts and then put them back together with the appropriate sign, okay? This is also not limited to two functions, okay? And this fact will work no matter how many functions we have got separated by plus or minus, okay? And the third property, limit x equals to a, and the f of x times g of x, it equals to limit x equals to a f of x times limit x equals to a g of x, okay? And we take the limits of products in the same way that we can take the limit of sums or differences. Just take the limit of the pieces and then put them back together. Also, as with sums or differences, this fact is not limited to just two functions, okay? And the fourth one, limit x equals to a f of x over g of x, it equals to limit x equals a f of x over limit x equals a g of x. And of course, provided limit x equals a g of x doesn't equal to 0, okay? And the fifth property, x equals to a f of x to the power of n, it equals to limit x equals to a, okay, and the f of x to the power of n, and where n is any real number. And the sixth property, limit x equals to a, okay, and the nth root f of x equals to nth root limit x equals to a f of x, okay, and the 7 limit x equals to a constant is equal to c, and the c is any real number. X equals to a, okay, and with the last one you should be able to convince yourself of this by drawing the graph of f of x equals to x, okay, and the 9th limit x equals to a, x to the power of n equals to a to the power of n, and this is really just a special case of property 5, okay. And when you take the f of x equals to x, you will obtain 9th property in some way, okay. And let me give you some example about this properties result. And compute the value of the following limit, which is the limit x equals to -2, okay, and the 3x squared plus 5x minus 9, okay, and the first time thought we will use all the properties above to compute the limit, okay, and firstly we will use the property property 2, which is the multiplication functions, okay, and to break up the limit into the 3 separate limits, okay, and we will then use the property 1 to bring the constant out of the first 2 limits. So that means it equals to, okay, limit x equals to -2, okay, and it's the 3x squared plus limit x equals to -2 and the 5x, and then minus limit x equals to -2, 9, okay, and it's equal to 3 limit x equals to -2 x squared plus 5 limit x equals to -2 x, and the minus limit x equals to -2, 9. Okay, we can now use property property 7 and property 9, okay, and you will obtain 3 times -2 squared plus 5 times -2 and the -9, and it will be, I think, -7, right? This is the result, and the okay, and let me continue another example, okay. And the same question, of course, evaluate the following limit, and which is the limit x equals to 3, okay, and the parenthesis minus 5 root x plus e to the x over 1 plus ln of x plus sine of x times cosine of x. And this is a combination of several of the functions, okay, and none of the restrictions are violated. So all we need to do is plug in x equals to 3 into the function to get the limit, okay, and it will be easy to evaluate. And that means minus 5 root 3 plus e to the power of 3 over 1 plus ln 3, okay, and the plus sine 3 times cosine 3. That's the result. And when you calculate this value, okay, you will obtain 8.1854, and we know that it's not a pretty answer, but we can now do the limit, okay? And now let's talk about the competing limits. In the previous section, we saw that there is a large class of function that allows us to use the limit x equals a f of x equals f of a, right? And however, there are also many limits for which this won't work easily. And the purpose of this section is to develop techniques for dealing with some of these limits that will not allow us to just use this fact. And let's first go back and take a look at one of the first limits that we looked at and compute its exact value and verify our guess for the limit, okay? And let me give this example and talk about it. And it was limit x equals to 2 and the x squared plus 4x minus 12, and it was x squared minus 2x. And first, let's notice that if we try to plug in x equals to 2, okay, and we will get 0 over 0, okay? So we can't just plug in x equals to 2 to evaluate the limit. So we are going to have to do something else. And the first thing that we should always do when evaluating limits is to simplify and function as much as possible, of course. In this case, that means factoring both the numerator and denominator, and doing this will give us x equals to 2, okay, and you will obtain x minus 2 times x plus 6 over x minus 2 times x, right? And when you cancelled this part, okay, and you will obtain limit x equals to 2 and the x plus 6 over x. So upon factoring, we saw that we could cancel an x minus 2 from both the numerator and the denominator, as you see. And upon doing this, we now have a new rational expression that we can plug now x equals to 2. So x equals to 2, you will see, okay, and it will be 2 plus 6 over 2, and it's equal to 4. Now, note that this is in fact what we guessed the limit to be, okay? Okay. And on a side note, the 0 over 0 we initially got in the previous example is called an indeterminate form, okay? This is indeterminate form. This means that we don't really know what it will be until we do some more work, okay? And typically 0 in the denominator means it's undefined. However, that will only be true if the numerator isn't also 0. Also 0 in the numerator usually means that the fraction is 0 unless the numerator is also 0. Okay, and so let me give you another example about this. And limit h equals to 0, okay, and 2 times minus 3 plus h square minus 18 over h, okay. Also in this case we also get, okay, when h equals to 0, and you put 0 values and you will obtain the 0 over 0 again, and factoring is not really an option. However, there is still some simplification that we can do, we must do, okay? And let me write it. Limit h equals to 0, okay, and it will be 2 times, okay, and then 9 minus 6h plus h squared minus 18 over h, okay, and it's equal to limit h equals to 0, okay, and 18 minus 12h plus 2h squared minus 18 over h, and it's equal to limit h equals to 0, okay, and minus 12h plus 2h squared over h, and so limit h equals to 0, okay, and the h parenthesis minus 12 plus, okay, 2h over h, okay, and this h will be 0. So when you put the h equals to 0, and you will obtain now minus 12, which is our limit function, okay. Now let's continue with another example. And the limit t equals to 4, and the t minus square root of 3t plus 4, and the 4 minus t, okay, and this limit is going to be a little more work than the previous ones, okay, and once again, however, not that we get the indeterminate form 0 over 0 if we try to just evaluate the limit, okay. Also note that neither of the two examples will be of any help here, and at least initially. And let's remember the, okay, rationalizing make use of the fact that the equation, which is about the a plus b times a minus b, it equals to a square minus b square, right? And when you these roots, this might help in evaluating the limit maybe, and the limit t equals to 4, okay, and the t minus square root of 3t plus 4 times t plus, okay, square root of 3t plus 4 over 4 minus t times, okay, t plus square root of 3t plus 4. And now limit t equals to 4, and the numerator part will be t square, okay, minus 3t, okay, minus 4 over 4 minus t times, okay, and the t plus square root of 3t plus 4 again. So, and you can use the numerator part like that. Limit t equals to 4, okay, and it's the t minus 4 times t plus 1 over 4 minus t times t plus square root of 3t plus 4, okay, and these parts will be cancelled but remain minus 1, okay, and so it will be equal to minus limit t equals to 4, okay, and the t plus 4 over, okay, t plus square root of 3t plus 4, okay, and when you put the t equals to 4 value, you will obtain minus, okay, and the 8 over, okay, 4 plus 4, so it's equal to minus 1, which is the limit function. Okay. Oops, I'm sorry, I think this part was not 4, right? Now this one plus 1, this one, so 5, and this will be minus 5 over 8. Okay, and let me give you last example. G of y equals to y squared plus y, 5, if y is less than minus 2, and 1 minus 3y if y is larger than or equal to minus 2, okay. So what can we say about the part A, okay, and when the limit x equals to 6 g of y, okay, we know that 6 interest is the right side of the piecewise function, okay, and the second side, I'm sorry, and 6 is larger than minus 2, so we can say limit x equals to 6, okay, and 1 minus 3y, so it's equal to minus 70, okay, and the part B, and the limit x equals to minus 2 g of y, okay, and firstly you must interested and you must look for the left hand side and the right hand side limits, okay, and the limit x equals to minus 2 from left hand side, okay, and you will obtain the y square plus 5, so it's equal to, okay, minus 2 square plus 5, and it's equal to 9, and the limit x equals to minus 2 from right hand side, It will be 1 minus 3y function, so it's equal to 1 minus 3 times minus 2, so it's equal to 7. I'm sorry, it looks like g, but it's not g. Okay, it's 9. And as you see, left hand side and right hand side are not equal to each other. So what can we say about it? We can say limit x equals to minus 2 g of y does not exist.